we're going to do a quick recap of multiplying out things of the form x minus a, x plus a. So let's start with something simple, x minus 3 times x plus 3. Remember, I've got to use the distributive law, so everything in this bracket must multiply with everything in that bracket. X times x gives me x squared. And then I need to do x times 3, and I'm going to get plus 3x. Then I have to do negative 3 times x, and that's going to give me negative 3x. And then I've got to do negative 3 times 3, and that'll give me negative 9. And what happens is that I'm going to have plus 3x minus 3x, so those are going to disappear, and I'll just be left with x squared minus 9. Okay, you try the next one quickly for yourself. Pause the video and do it now. So hopefully this is what you got. And again, you have this situation where you've got plus 5x minus 5x, so those terms with x just disappear, and you're left with x squared minus 25. And then pretty soon after working with this pattern, you don't even actually need to go through the steps, because if you're presented with something like x minus 4, x plus 4, you know that what you're going to say is x squared, and then the minus 4x and plus 4x will disappear with each other, and so 4 squared is 16, so it'll be x squared minus 16. And this is why we end up calling something like this a difference of two squares, because what you end up with is x squared, and then you've got 3 squared, so you get 9, and then you subtract them, it's a difference. X squared, 5 squared, and subtracting. And this pattern means that even if it looks revolting, it's actually really easy to do. If we've got this, where we've got the same thing here, the only thing that's different is this is got a minus and this is a plus, we're going to get out a difference of two squares. So the first term is going to be 2x squared, and it's a difference, so minus, and then our last term will be 3y squared, and this 2x squared, 2 times 2 is 4, x times x is x squared, 3 times 3 is 9, y times y is y squared. And we don't have any other term because the minus 3y 2x will disappear with the plus 3y 2x. We're going to start working towards a point where we can factorize a difference of two squares. We've already discussed a little bit about what factorizing is, but let's just remind ourselves. We can be given something like this, and we get asked to multiply it out. This is what we're very used to doing. We multiply out, and we get x squared minus 9. But we could start with x squared minus 9 and then be asked to work it back to this form. And when we do that, we talk about that we are factorizing. And when we head towards factorizing, what we're really going to be doing is reversing what we did with multiply out. So if we started over here, how would we know what to go here? Well, we'd have to recognize x squared minus 9. We know that pattern. It comes from an x minus something, x plus something pattern. And how do we know what the something is? Well, we said 3 times 3 to get 9. So basically what we've got to do is go backwards and say, well, what times what will give me 9, and get the answer of 3. Let me show you a little bit of what I mean. Imagine I started with x squared minus 16, and I asked you to factorize it. Then what I'd be asking is for you to get it in the form x minus something, x plus something. What is that something going to be? Well, we know that when we multiply out, it would be this times this must give you 16, and it must be the same thing. And so we know what times what gives you 16. It's the square root of 16, which is 4. So the reason I've put this little table on the side is it's going to be very helpful if you know this table really well, because then if you see x squared minus 81, for example, you'll immediately know that it was x minus 9, x plus 9. Now let's have a look at a monster like this we might want to multiply out. We recognize immediately we've got the plus, the minus, and everything else is the same. So we know we're going to be in a situation where our answer is going to be 4x to the 8 squared minus 3y cubed squared. Now let's watch what happens when we square. When we square, we've got 4 times 4, which is 16. And then we've got x to the 8 multiplied by x to the 8. And so we're going to get x to the 8 plus 8, right? So we're going to get x to the 16. And here we're going to have 3 times 3, which is 9. And y cubed squared just means you've got y cubed multiplied by y cubed. So you've got 3 y's multiplied together, another 3 y's multiplied together. In total, you've got 3 plus 3, which is 6 y's. Now, why am I making such a big fuss of that multiplying out? Because where we're heading to is I want us to be able to factorize this. So I want us to get to a position where we can then say, where did this come from? It came from something minus something, and then the same thing plus something. And to figure that out, we know we've got to take the square root. So basically what we're asking ourselves here is, to find out what goes here, I need to know what multiplied by itself will give me 16x to the 16. Well, we know that 4 times 4 gives me 16, so there's definitely a 4. And then for our x's, we have to in total end up with 16 x's, so in each place here we've got to have 8 x's. And similarly, for figuring out what goes over here, I'm asking myself what multiplied by itself will get me to 9y to the 6. The numbers are easy. 3 times 3 gets me to 9. How many y's? Well, in total I want to have 6 y's multiplied together, so I need 3 here and 3 here, which means the fully factorized form is this. Let's look at factorizing a difference of 2 squares. So we've looked at over the last couple of videos very strongly this idea that if you take a minus b and multiply it by a plus b, you just get a squared minus b squared, your difference of 2 squares. Now what we're wanting to do is, instead of multiply out, we want to go the other direction and we want to factorize. So we're going to start with this and we want to get back to that. So if we're asked to factorize x squared minus 25, what we're being asked is to get the 2 brackets that multiply together. We know we must have a minus in one and a plus in the other. And then we need to have the first term has to get us to x squared when we multiply it together. So it's obviously going to be an x and an x. And this needs to be the same thing multiplied together to give you 25. So it will be a 5 and a 5. Why don't you try the next 2? Pause the video, try it for yourself, and then we'll go over it. So as soon as you recognize that you've got a difference of 2 squares, you know when you factorize it you're going to get 2 brackets, one with a minus, one with a plus, and now you've just got to figure out what these are. We know that what goes here must be the same thing multiplied together to give you 25, so obviously what goes here is 5, and then what goes here must be this times this must give you x squared, and so obviously it must be x. For this one, this times this must give you a squared b squared, so it must be ab. And this times this must give you 36, so it must be 6, because 6 times 6 is 36. What about this thing here where we've got x squared plus 25? The important point to notice here is that we do not have a difference of squares. We do have a square, x squared. We do have a square, which is 5 squared for 25. But we don't have a difference. We've got a plus. And it turns out that this can't be factorized. We're going to do some more work on factorising the difference of two squares. These are going to be harder than what we've done previously. So if you haven't mastered what we were working on previously, really I'd suggest you do those first before you continue on to these. If we're asked to factorise something like this, the very first thing you always need to do when you're checking for factorising is to see if there is a common factor that you can take out. So remember, that's what we started with in factorising, just taking out a common factor. So if we have a look over here, is there something that can divide into 3 and also into 12? Well, yes, there is. 3 can. And then, is there something that can divide into x and x? Well, yes, x can. And so what are we left with? We're then left with y squared. And from the 12x, we are left with minus 4. And now we have got a difference of two squares, and so we just factorize. So here's the important idea. We must always look for a common factor first. We could also be faced with a monster like this one. First check for common factors, but there aren't any here, right? You've got A's and B's in the first one and C in the second, and you've got a 25 and a 9. They don't have a common factor. So what we hopefully can see is that we do have the pattern of a difference of two squares here. And all we need to do is go back to what we were doing right at the start, which is recognizing what the square root of each of these things are. So let's have a look at 25a squared, b to the 6. So we're asking ourselves what multiplied by itself will give us 25a2 b6. Well, we know it has to be 5 multiplied by 5 to get us to 25, and a multiplied by a to get us to a squared. For b to the 6, we want to end up with 6 b's multiplied together, so in each of these we need 3 b's multiplied together. So we get 5ab cubed here. And then for this other one, we're asking what multiplied by itself will get us to 9c to the 16. Well, we know that 3 times 3 gets us to 9, so that is no problem. Then what power do we need to put with the c's? Well, we want to end up with 16 c's multiplied together, so we need 8 c's here and another 8 c's multiplied together there to get us to that. And so here is our nicely factorized form. Okay, try this one for yourself. Factorize x to the 4 minus 16. Pause the video and try it now. Okay, so you should have recognized it as a difference of two squares. So you're going to have that pattern. And to get to x to the 4, you're going to have x squared times x squared. And for 16, you're going to have a 4. But did you recognize that this is still a difference of two squares? And so in fact we can continue with our factorizing. We can't do anything with the x squared plus 4, but we can go on here to say this is x minus 2, x plus 2. So we've done a bit of factorizing now. So let's do a bit of practice by looking at some questions that I've got from various past exam papers from various schools that deal with factorizing. I suggest that you get a pen and paper and see if you can work on these alongside me, because it'll give you a good sense of where you are. Okay, let's have a look at question 1. What would be our first step in working on this? So here, hopefully you recognize that what we have is a situation of taking out a common factor. And in fact, that's what we always look for when we're factorizing. The first thing we look for is a common factor. So here, if I have a look for the numbers, it's 3, 9 and 12. So the highest common factor there is going to be a 3. Then the x's, they've got an x squared. Let me put the 3 down first. Then I've got an x squared, an x cubed and an x squared. So the most I can take out is x squared, and then the y's, y squared, the most I can take out is a y. All right, so then looking at what's left from here, I've taken out a 3, taken out an x squared, taken out a y. So I just need to put a 1 in, because 3 x squared y times 1 gives me 3x squared y. All right, now focusing here, I've taken out a 3, so I've got a minus 3, because minus 3 times 3 gives me minus 9. From the x cubed, I've taken out an x squared, so I've got x left. From the y squared, I've taken out a y, so I've got y left. And then I look at my last term, and what's going to be left of the 12? 12 divided by 3 is 4. From the x squared, I've taken out an x squared, so nothing left. Y squared, taken out a y, so there's just y left. And there's nothing more for me to do there. Okay, have a look at 1.2.2. First, you always look for a common factor, but there's no common factor here. All right, after that, can you recognize the format of this one? Hopefully you recognized it as a difference of 2 squares. So we know that we're going to have 4x times 4x to give me 16x squared, and a plus 1 minus 1 to give me the minus 1. Okay, what about this one? What's always our first step when we're factorizing? We look for a common factor. And here we do have a common factor, because 2 divides into 2 and also into 18. So we're first going to take out that common factor. And then we end up with this scenario. Do you recognize 9a to the 4 minus b squared? What kind of factorization would go with that? Hopefully you also recognize that that is a difference of 2 squares. So the b squared is very easy, right? That must come from plus b minus b. Your 9, no problem. 3 times 3 gives you 9. And what about your a to the 4? Well, it's going to be a squared multiplied by a squared, which gives you a to the power of 4. Okay, what about 1.2.4? First thing we always look for is a common factor. Now there is in fact a common factor here. It's just a really strange looking common factor. Do you see that each of the terms has got p minus 2q in it? So p minus 2q is the common factor here. So just as we've always done with common factors, we can pull out that p minus 2q. What is left from here? Well, we've pulled out the p minus 2q, so what's left is the r. And what is left from here? Well, we've pulled out the p minus 2q, so we've just got to put in a 1, because 1 times p minus 2q will get us back to p minus 2q. And so we have factorized as asked. Okay, the last one we want to factorize is this. So again, as always, we look for a common factor first. Now, if I look through all of these, there isn't actually a common factor for all of them, because if this one, although this one has an a and this one has an a, these two don't. And although this one has a b and that one has a b, those two don't. So there isn't a single common factor that goes through all of them. The one thing I can try out is to see if I can group them and take common factors out of 2. So you see, if I have a look here, if I'm playing around with this a bit, I see that one and that one have an A in them, and this one and this one have a D in them. So I can go ahead and let me just kind of put them together next to each other so it looks a bit prettier. So there are my 2 ones that have got an A in them next to each other. And then here are my 2 that have got a D in them next to each other. Now, if I just work with them as little pair groupings, out of this one I can take out an A and I'm left with B plus C. And out of this one I can take out a D and I'm left with C plus B. Now, B plus C and C plus B are exactly the same thing. So what I've got here is A, B plus C, and D, B plus C. And now, just like the previous one, I've got a common factor. It's just a very funny looking common factor, B plus C, but I can pull that out. So I pull out my B plus C, that funny common factor. What am I left with from the first thing? Well, an A. What am I left with from the second term? A D. And I've factorized completely.